In this lesson we're going to continue to look at addition polymers, and we're going to look at some other examples. Before we do so, let's just remind ourselves about polythene. This is the basic monomer used to make the polythene polymer, and we remember that these can consist of chains that are really very long, anything between 4,000 to 40,000 carbon atoms in one chain. And we can write the equation in this way, where we've got n monomer units being polymerized into a polymer with n polymer units. So this is the repeated unit in the polymer chain, and we said that this reaction takes place using a catalyst at high pressure. Now there's just one thing I'd like to mention about the production process here, that the pressure can affect the type of polymer that's produced. So when we use very high pressure in this process, what tends to happen is this polymer chain forms branches. So if I represent the polymer chain like this, okay, under high pressure, that's pressures of up to 1,000 atmospheres, you get branches formed. Okay. And that's typically, very high pressures, up to 1,000 atmospheres. And as a result of this branching, the polymer molecules can't pack together very easily, and so as a result the material has a lower density. So we call this low density P poly and then E for ethylene. So I should have mentioned this before, that the old-fashioned name for this polymer, polythene, is polyethylene. Okay, so it's also known as polyethylene. So this occurs when very high pressures are used at over 1,000 atmospheres. If we lower the pressure down to around about 100 atmospheres, then this branching stops. And so what you get then is linear chains, okay, like this, which can pack together much more closely, and so that increases the density of the material. So this will be happening at around about 100 atmospheres. So we've changed the production process now to produce what we call high density polyurethane due to the lack of branching, closer packing, and subsequently higher density. So we're going to look at a few more examples of addition polymers, and in each case what's going to happen is we're going to replace this hydrogen in this ethene group with some other functional group. And that's going to change the monomer, which will change the polymer and produce a different type of plastic. So first of all, we're going to replace the hydrogen group with a methyl group. So in fact what we've got here is simply another alkene called propene. That's 3 carbons, 1 double bond, and you can see this polymer unit repeating itself in the polymer. So the name of this polymer is going to be polypropylene, and more commonly known as polypropylene, which is used in the manufacture of heavy-duty plastic crates or ropes, for example. So let's have a look at another example. This time we're going to replace the hydrogen with this benzene molecule. Okay, that's 6 carbon atoms joined in a hexagonal chain. So this actually has a structure, this benzene C6H5. And again, you can see the unit repeating itself through this structure, and the name given to this monomer is styrene. So the polymer is polystyrene, which you would have heard of, and that's very important for packaging, and it's used in the food industry to make food packets, for example, when you buy beef burgers or whatever. And I should also mention that in this process, as with the polymerization of propene to produce polypropylene, the same basic principles are applied as with polythene. That's to say, we're taking our monomer under high pressure and using the same type of catalysts to generate the polymer. Okay, and last of all we'll look at another important monomer. Okay, we've replaced the hydrogen with a chlorine atom. This molecule is chloroethene. Its old-fashioned name was vinyl chloride, so the polymer retains the old-fashioned name, as seems to be the way with most of these, and is known as polyvinyl chloride, or PVC. and that's used to make plastic plumbing tubing, okay, PVC. Again, you can see the polymer unit repeating itself throughout the polymer, and again the same principles apply in the production process. You've got high pressure with a catalyst.